dielectric medium. So previous class we started the capacitance of a parallel plate capacitor. So second one, capacitance of two dielectric medium. Capacitance of two dielectric medium. So actually a capacitor will be consisting of two plates. On one plate you will be having positive charge, on other plate you will be having a negative charge. It is separated by a distance d. Some voltage will be applied. So here instead of having a single dielectric, here we have two types of dielectric. So first layer of dielectric is at a distance of d1, second layer d2. d1, d2. So dielectric material epsilon R1, epsilon R2. So your voltage is treated as V1, V2. V1 and V2. So for any dielectric, that is electric flux density, D is equal to Q by A. Yesterday from Gauss law we derived closed integral of D dot ds will be equal to Q, charge Q. So ds can be represented in terms of area. So ds means it is length into breadth. Area is also length into breadth. So we are replacing instead of ds as A. So d is equal to Q by A. We also know what is d. D will be equal to epsilon E. Therefore we can write epsilon naught. Epsilon is equal to epsilon naught epsilon R E equal to Q by A. From this we can find E is equal to Q divided by epsilon naught epsilon R A. E value Q divided by epsilon naught epsilon R A. So for two dielectric we can write from this diagram supply voltage V will be equal to V1 plus V2. So how to relate V and E? V and E. We know E is equal to V divided by D. So therefore V will be equal to will be equal to E into D. So V1 is equal to E1 D1 plus E2 D2. So from this expression find E1 and E2. So E1 means it is Q divided by epsilon naught epsilon R A இருக்குமா generally E is Q divided by epsilon naught epsilon R A. So for 1 take it as epsilon R1 and D1 plus Q divided by epsilon naught epsilon R2 A into D2. So from this expression we can take Q divided by epsilon naught A as a common term. Therefore it is D1 by epsilon R1 plus D2 by epsilon R2. Taking LCM, Q divided by epsilon naught A into epsilon R1 epsilon R2 epsilon R2 into D1 plus epsilon R1 into D2. Correct? So this is your V value. Actually we need to find capacitor C. What is C? C is equal to Q divided by V. So Q divided by V. Substitute your V expression here. So Q divided by epsilon naught A into epsilon R1 D1 plus epsilon R1 D2 divided by epsilon R1 R2. So here Q will get cancelled. Therefore, capacitor C will be equal to epsilon naught A epsilon R1 epsilon R2 whole thing divided by epsilon R2 D1 plus epsilon R1 D2. Capacitance of two dielectric medium. Similarly, solve for capacitance of three dielectric medium. Third topic, capacitance of three dielectric medium. Capacitance of three dielectric medium. So your capacitor will be remaining same with one end has positive charge, other end has negative charge. In between that you will be having a voltage V. Area is remaining constant A. Area is A. Instead of two types of dielectric, here we are going to include three types of dielectric. Therefore, first layer will be dielectric 1 epsilon R1, second one dielectric 2 epsilon R2, third layer epsilon R3. So voltage across this is V1, V2, V3. Then distance is taken as D1, D2, D3. So from this equation, what is V? V will be equal to sum of V1 plus V2 plus V3. So V will be equal to sum of V1 plus V2 plus V3. Q divided by epsilon naught epsilon R1 A D1 plus Q divided by epsilon naught epsilon R2 A D2 plus Q divided by epsilon naught epsilon R3 So Q divided by epsilon naught A into epsilon R1 R2 डायरेक्ट सी कर दिया R1 R2 R3 is equal to epsilon R1 R3 D2 plus epsilon R2 R3 D1 plus epsilon R1 R2 D3. Right now. So this is your D equation. So finally find C is equal to Q divided by D. By substituting, you will be getting A into epsilon naught epsilon R1 R2 R3 divided by epsilon R1 R3 D2 plus epsilon R2 R3 D1 plus epsilon R1 R2 D3. Composite parallel plate capacitor. Composite parallel capacitor we have two dielectric medium nu sonoma. So it is placed in such a way that your area remains constant. Correct? Area ன்றது அப்படியே plus minus அதுக்குள்ள இருக்கிற dielectric அத ரெண்டா பிரிச்சுட்டோம் மூணா பிரிச்சுட்டோம் different layers. Here in composite parallel plate capacitor, instead of replacing that is splitting your area, your distance will be maintained constant. That is your distance d1 is similar to distance d2. So composite parallel plate capacitor means d1 will be equal to d2. Okay, so in general capacitor, in a capacitor area will be remaining constant. In between that you will be having a dielectric. adala da nam enna pannirkom single dielectric na parallel plate capacitor, two dielectric na two dielectric parallel plate capacitor pathom, three dielectric parallel plate capacitor pathom. So next one is your composite parallel plate capacitor. Composite parallel plate capacitor na based on your dielectric medium your distance got varied in a normal parallel plate capacitor. Composite na one mela one layer இருக்கும்போது your distance is maintained constant. That is d1 will be equal to d2. Similar expression now. So here if a voltage is applied across it, so this layer will be V2 and this layer will be your voltage V1. So V will be equal to sum of V1 plus V2. What is V in terms of E? E into dr. So it is E1 D1 plus E2 D2. We know D is equal to epsilon E. So E is equal to D divided by what is your final capacity value? So if D is taken common, D1 and வச்சிட்டோம்னா E1 plus E2 தானே. E1 plus E2. E in terms of D is equal to D by epsilon. D in terms of area. Capacitor நால என்ன இருக்கணும்? Area இருக்கணும். அப்பனா D will be equal to ds அந்த ரிலேஷன் இருந்தது. dA QA வா? D is also equal to Q by A. என்ன பண்ணேன்னு புரியுதா? Why na in a capacitor capacitor should be replaced in terms of epsilon A divided by D. அப்ப ஏரியாங்கிறது வரணும் இல்லையா? So ஏரியா வேணும்னா எனக்கு என்ன எக்ஸ்பிரஷன் யூஸ் பண்ண முடியும்? A will be in terms of D. சரியா? அப்ப D வேணும்னா இங்க E தான் இருக்கு. So D யும் E யும் ரிலேட் பண்ற ரிலேஷன் D is equal to epsilon A. அதுக்காக இப்படி ரிவர்ஸ் கொண்டு வரும். ஓகேவா? Capacitor final answer should be in terms of area. So for bringing that term we are replacing E. For bringing this D term we are replacing your E term. சரியா? Solve it, find what is C. இல்லைன்னா find D. So D1 by epsilon naught epsilon R1 plus D2 by epsilon naught epsilon R2. Next step, D can be replaced by instead of D1, if you are replacing Q by A na Q1 by A1 ன்னு சொல்றீங்களா? Q by A தான்.
ஆமா அது வந்து டேரக்டா வெளியவே Q by A1 தான் வெளிய சப்ஸ்டிட்யூட் பண்ணிட்டு.
அதான் சொன்னேன் நீ சால்வ் பண்ணி நீ சொல்லுன்னு சொன்னேன். நீ சொல்லல அதனால நான் ஏன் சொல்லி போட ஆரம்பிச்சிட்டேன்.
இது போட்டு சொல்லலாம்.
So B will be equal to, so that correct now, D1 into, instead of capital D1 it is Q by A epsilon naught epsilon R1 plus Q divided by epsilon naught A epsilon R2. So Q D A epsilon naught, if you take common you will be getting 1 by epsilon R R1 plus 1 by epsilon R R2. Correct? Final expression B is equal to QD divided by A epsilon naught 1 by epsilon R1 plus 1 by epsilon R2. Find what is C. C is equal to Q divided by B. Substituted Q will get cancelled. Therefore, A epsilon naught divided by D into LCM எடுத்துட்டு சொல்றேன். So take LCM. By taking LCM, QD divided by A epsilon naught into epsilon naught R1 epsilon naught R2 in numerator R2 plus epsilon naught R1. So this is your B expression. Since C is equal to Q divided by B, C will be equal to A epsilon naught epsilon R1 R2 divided by D into epsilon R1 plus epsilon R2. Fifth one, capacitance of a coaxial cable. Coaxial cable. Coaxial cable பார்த்துட்டீங்களா? Real time coaxial cable.